Hey everyone, so nearing the end of the Internet of Holiday Lights challenge, and it's finally come down to putting all of my pieces together. Been quite a challenge over the holiday period. I didn't expect it to consume so much of my time in order to try and do a good job of this, but I committed to quite a extensive project at the beginning. I wanted to have at least a representation from Texas Instruments, Arduino Uno, Arduino Mega, Arduino Yun, and also various different kinds of lights, obviously including the Infineon board that we were provided as part of the challenge. But I wanted to include NeoPixels and some other craft stuff, and of course minions. Anyway, so now's come the time to start putting everything together. So the first thing I'm doing is I've got a Raspberry Pi here, which isn't communicating with anybody, but it's providing a bit of background light show, which is what I stated it probably would end up doing at the beginning of the project. At least I think I did. Either way, that's what it's going to be doing now. So I'm just going to get that put together. So not everything is hooked up to big outside lights. In fact, nothing is hooked up to big outside lights. At the beginning of my challenge, one of the things I think I made reasonably clear was that I wanted to demonstrate how to make all of these things interoperable and drive the lights and allow them to communicate with each other, both using the PAHO Internet of Things website, the eclipse.org MQTT broker, using as where I can the PAHO libraries as well, of course, and getting all of these boards to talk to each other wirelessly using NRF or sub-gigahertz or 2.5 gigahertz wireless links, but not Wi-Fi, except for the main communications to the house. So I think I've got a pretty good representation of that as well with this project, and now I'm just going to finish putting it together and we'll see how well it all works together. So the first thing we have here is Raspberry Pi Model B. It's not the B+, it's just the B, so it's got the big SD card still. This one is hooked up to the two of my panels that I got from Adafruit, which are these big LED panels. So I've got two of them hooked in series, and all it's going to be doing is sending messages to just replaying little Christmassy kind of themed message, just scrolling it across the display. It also acts as a monitor for all of my messaging. I just run a couple of MQTT subscribers that subscribes to all of the channels that I'm trying to use. So we'll have a screen up that can show us everything that's happening as far as traffic up and down. I think I have 4 or 5 separate channels running up to the PAHO Eclipse web servers for running the MQTT stuff. So it seems to be all working fine. I'm probably driving our Belgium contingent nuts with all of the different messages that keep showing up on his side of the pond. But you will see as we go along that I'm actually leveraging that shared community topic as well as part of this demonstration. Anyway, let me just get the Pi hooked up and we'll come back. Okay, welcome back. Finally got everything set up. Minions have been helping. As you can see, they're scattered everywhere. So what have we got? Well, in the challenge I said that I wanted to have battery powered. I wanted to have the Yun acting as the communication center. So the Arduino Yun is right here, and I labeled her as Mrs. Yun, and she's the host of the party. We've got Lightstrip Larry, the Mega Star, using an Arduino Mega. That's driving this top it's not a NeoPixel, sorry, top LED matrix display with all the dancing balls and everything else. As well as that, this particular display is also connected to an NRF24L01 so that it can listen to Mrs. Yun, because it doesn't have Wi-Fi access, it just has a local radio. The one we have over here with the star busy doing automatic patterns right now is Mr. Uno, star of the party, obviously Mrs. Yun's husband, running sequencing for the lights. Also has an NRF24L01 attached to it, and is able to right here, and is able to take instructions from either MQTT via the internet through Mrs. Yun, who relays them onto him, or through the serial communications. Now I don't have any serial communications connected at all to any of these. The only reason that there's USB connections onto a lot of them is because it's just to power them. And it's getting a bit crowded on the desk here. The other one I've got here is the Arduino Uno with the Infineon RGB controller on it. It's actually connected to the LED strip that's wrapped around sitting on the desk here, that's just lightly illuminated, sort of like a turquoisey color. Minions are around making sure everything's working okay. Over on the left hand side here we have Raspberry Pi. Can you see that there? Yep, probably can if you zoom in a bit. I'll do a closer run through these in a moment. And the Raspberry Pi at the bottom, at the back here, as I anticipated at the beginning, I wasn't able to get enough I/O left on it to hook up an NRF24L01 to it, as well as having it driving this display. Now these displays, each panel is a 32 by 64 pixel matrix. So the Raspberry Pi down here is driving a 32 by 64 times 2, so it's basically 32 by 128 pixel display, which is pretty awesome. And that's happening in real time right from this Raspberry Pi here. The one at the front here is where we had one of our foreign guests. This is a Texas Instruments CC3200, and he's running on batteries because he doesn't like the local juice, so he brought his own. And this one is listening directly via its wireless interface to MQTT. The PowerHole libraries are being used, and it's listening to the eclipse.org website. I've actually told it to listen to the Element14 IoT stream, and I've got 4 outputs configured for this one, and each light is configured to turn on if a particular top member pings the Element14 IoT topic that we currently have set up on the Eclipse PowerHole site. So what I've got here is this board is actually hooked up via a relay board here. This is an 8-channel relay board, and I have some high-powered LEDs hooked up as well. Don't know if you can see those there. As I said, I'll go do some close-ups. And when there you go, there's one of them. That would be yep, there's another one. So about every 30 seconds everybody is pinging in. So I have 3 lights on here illuminating 3 of my minions, just to let them know, you know, they're being watched. And I've also got the 4th channel over here hooked up to one as well. And I think the 4th one, if I remember rightly, I've got to go find my monitor to see which one's which. Yeah, so that was me, so the 3rd one on here. We've got Jan, we've got MCB1, which just lit up this one, and one over there. So yeah, any one of the 4 top members, myself, Van, Mark, or Jan, if we ping that site, it'll turn one of these lights on for about 5 seconds. So I'm just keeping it down because I don't have very big heat sinks on these, so I've just turned them down from a timing perspective. But I wanted to demonstrate how you can take a 3.3 volt microcontroller and actually have it driving through an LED board to some high-powered LEDs. Now, we've had this discussion many times on the forum where we've said, you know, don't buy these these relay boards from China and expect to be able to hook mains directly to them. It's a little dangerous because, you know, the circuitry underneath is exposed, and you run the risk of electrocuting yourself if you really don't know what you're doing. And not all of, you know, there are some boards that have been designed well enough to comply with local regulations and things, but you know, you just don't know because they're not CE approved or anything like that. So if you're going to use one, then use it for switching things like 24 volts and stuff. So these LEDs on this board, they run at about 12 volts each one. So what I have is I've got 3 of them. I've actually turned my power supply down to 9 volts because I don't want to blind the minions or myself while I'm trying to video this. And also I've set the current limit so that I don't overdo it, and each LED has a little 2 ohm resistor just to keep it balanced a little bit. The one over this side is actually a pair of 3 volt LEDs. They're lower powered ones, but I've got them both in series. So the power adapter for this one up on my power supply is set to 6 volts, and that's just connected to another one of the relays. So that's all being driven, as I said, by the CC3200. It's completely autonomous. It's not, Mrs. Uno is not talking to it at all. It's listening via its own Wi-Fi connection out to the internet, to the Eclipse website. So I think, have I forgotten anybody? I hope not. This is a party and we want to make sure we've got everybody. So we've got Texas Instruments is represented. We've got the Arduino Uno, the Arduino Mega, Arduino Yun, Arduino Mega, Arduino Uno times 2. Oh, of course. Baby Bob is sitting here. Now, as I said a couple of weeks ago, Baby Bob doesn't have communication skills right now, but Baby Bob is paying attention, and right now, because I'm moving around in front of him, he's woken up and he's got his like nice happy green lights going on. If I try to go too close and trying to grab his susu, as you can see, he kind of gets a little bit upset at me. So if I back away a bit, he'll get a bit happier, and now that he knows that I'm close, oh, not close enough, there. All right, so I'm a bit far away, but he's happier. He knows I'm there and he can sense me. Now he's doing some color cycling. So Baby Bob here is all about somebody being close and paying him attention, but not connected via Wi-Fi or anything else. So, you know, if I go away, I've shown you on a previous video that he'll just go to sleep if I ignore him. But anyway, I think that's everything. Oh, yes, sorry, that's not quite everything. One of the other things that I've done, and I can show you on my tablet right here, once it comes back up again, is created a complete adaptation. Originally, Benjamin K would put together a small demo for the Infineon RGB shields. So what I've done is I've taken his initial concept and I've extended it. So we've still got the color wheel up the top here, which can control the colors of the LEDs over there, and I'll give you a closer demo of that in a moment. You can probably see them changing in the background as I'm touching this thing. If I move it out the way, there you go. Now you'll be able to see it. Right, changing all the colors. Just clicking around on the wheel. But what I've added to this is I've added some buttons here which actually talk to the star that I've got running. So right now it's running in auto mode, but if I press one of these buttons, I can actually get it to stay. It's there. It's just flipped into expand 2 mode now on the side there, and it's going to stay there. If I then go to say rotate, once it's finished its expand mode, it'll flip back to a rotate mode. There, okay, and it should stay there in rotate mode now. The other part I've got down here, which I haven't mentioned yet, is I've got 2 gauges on this page as well. I'll put some close-ups on the forum and also with the camera in a moment. And these are actually monitoring the temperature. The Texas Instruments board here has got a temperature sensor built into it, and it's transmitting that up on a topic to the Eclipse website as well on their MQTT broker, and that's actually being monitored by the web page in this case. So the actual HTML page has subscribed to that topic and is bringing in the pages and actually in real time adjusting these gauges, and I'll demonstrate that again in a moment as well. And I think that's pretty. Oh, sorry, there's one other piece here. So as a few of us have already been playing around with, we've got a 30-second poll going up to the MQTT server, the Eclipse, and we have a topic, Element14 IoT. Now what I've got here is that this, I can actually inject an additional text message, and what will happen is if I time it right, it'll actually show up on the screen. That's just Mark's one just gone round there, but if I wait for it to come around a bit, so Happy New Year, let me just send that now. It should say hello. There you go. So it's saying hello this time. All right, and it's going to change any second because between 4 of us pinging the MQTT server, it gets quite busy, as you can hear the relays clicking in and on and off all the time as well. So let me just put this back down a second, and I'll pick the camera up. So this is the display that I put together. As I say, the color wheel on this left-hand side here was the one that Benjamin Cabe gave us a demo of, driving the RGB LEDs. At the bottom here, though, as you can see, we've got these extra, I'll take some actual static snapshots and put them on the forum page, and these are the 2 gauges that are currently monitoring the party room and the dance floor. As you can see, the dance floor is a little bit hotter. Now, the reality of what this is technically is that the temperature sensor that's built into the CC3200 has 2 sensors on it. One is the measuring the room temperature, which is the one that I have sending to the party room, which is reading just over 20 degrees, or 22.08 to be precise. And the other sensor that's built into it is actually measuring the silicon temperature of the sensor itself. And that one is reading slightly higher, of course, because it's active and powered, so it's reading about 25.25. And you can see there it's actively changing. So this thing, every time, I think I send the updated temperature, I think every 5 seconds. So every time it sends it, it's going to update these analog displays here. Now you can make these anything you like. I just happen to use analog ones because I knew how to use those. So yeah, it's working pretty nicely. So let me just go over to close-ups of some of these other pieces. So this is the relay board that I've been using. I got it from China a long time ago off of eBay. And they're pretty good, except that, as I said, you got to be wary if you're trying to put mains on them. I don't have mains on these. I'm just running 10 volts through them right now, and it's being controlled by this CC3200 board. I'm just being careful here because I've got wires flying everywhere. I've just got them pushed into the bottom and onto my breadboard and then looping them across. It's subscribing, as I said, to the Element14 IoT topic, and it's been told if it sees MCB1, FN, Jan Combs or Peter Oakes, it will turn on one of the 4 relays. If I just leave that watching that for a second, you'll see it any moment. Right now it's probably got well, there's none on. That's just a power light that you can see there at the moment. Okay, there's one, and that happened to be, if I bring up my Unix monitors. Alright, that was me, then MCB1. Now they've both gone off again, so the next one that comes up, I'll tell you when it comes up. There, that was MCB1 again. No, that was a relay going off. Yeah, that was Jan and Van just came in, so that's like 2 and 3. And you'll see, rather bright that they are, but no, there's all 3 on now. And we're missing one, which is probably MCB1, which should put that relay on over there, that light on that one, when it comes in again. Is it going to go? Come on. There we go. MCB1, like I said. So as I say, I've got the brilliance of these LEDs turned way down because otherwise it would just whitewash all of my videoing. So I'm just moving back a bit. Now I'm just going to, the bottom board that you're seeing there now that's scrolling across, that is just connected to the Raspberry Pi, and it's just a static message that it's scrolling through. The demonstration there at the moment is that you know, even though it's a Raspberry Pi and a lot of people think that they can't do too much with it, this is currently running, as I said, 32 by 128 pixel LED display, which is pretty impressive, and it's doing that effectively in real time. The top one is being driven by the ATmega 2560, so it's Arduino Mega board, and it's actually the bottom one is running an image through. There's a program in Python you run, it creates an image and then you scroll that through as a bitmap. The top one on the Mega is actually taking text and calculating through a font library the exact screen, and basically working like a TV screen where it's going to raster it down. And these displays actually are rastered, they're not static. So if I actually unplug the micros, you'll see that there's only 2 lines ever on at the same time because they're addressable and you have to scan them to make them work. So this top one, as I say, it's being driven by an ATmega, which is pretty good. There you go, let's just switch to me. You can see the messages switching as they're coming in, you can hear the relays. So I'm just, the text that says Happy New Year is built into the ATmega, and what it's doing is adding the name of whoever sends a message via the MQTT server. And if I actually go to mine and I just go in and say hello on it, just give me a second, I wait for it to be coming through. Of course, if somebody else sends right at the wrong moment, it'll override it. There, I just see. I tried to do that, and at exactly the moment I did, the other one's pinged it again. So it's hard to deliberately inject one and see it unless I tell it to ignore the rest. Everybody's pretty active sending stuff right now. I'm just going to send it any second now. So there you go. Hello. That's what I just put in. It went back to Jan again. So that's the ATmega 2560 Arduino Mega board driving that one. The LED string here is being driven by this board, which, as you can see, it is the Infineon RGB board sitting on top of an Arduino Uno. These here are for the wireless radio. They're all sitting quite close. I got so much interference over all the equipment I've got around here that it's almost impossible to get any decent signal integrity around here. So as soon as I start moving them any further apart, I just can't get a proper signal. So I've had to put them relatively, well, very close to each other right now to make it work properly. I think that I'm going to be investigating using those new Wi-Fi modules. I've got some on order. They just haven't arrived yet. Otherwise, they'd be in here. Anyway, that's the Infineon RGB board. I've already done a little bit of a write-up on that on some of the previous blogs. But just to show you, here's the screen. All right. Now I'm going to twiddle on the screen while you guys. I'm just going to keep the camera. I don't know if I can keep it on both right now. Can I? Not easily. So I'm just going to change it to red. Just going to slide my finger around the wheel, and as you can see here, it's quite happily rotating around the different colors. All right, so this is again firing into the PAHO using the PAHO libraries, and it's firing up into the Eclipse web. Sorry, it's using the Eclipse MQTT servers with the web services interface that they have for it, using the standard PAHO libraries, and that works very, very well. As you can see, I can just tweak away, changing the colors, and all I'm doing here is a touch screen that I'm just touching. You can actually see them if I try. Oh, there you go. I can get it in now. So as I play with this, I can bring them almost off down here, bring them up really bright, and twiddle the colors around. Blue, purpley, towards red, yellow, back to green. And that's all working very, very nicely. Like I said, the star over there, so right now that's running, I think, in auto mode. So if I tell it to go expand mode, it should flip once it's finished auto mode and go into an expand mode. These are using Neopixels internally. There, it's running expand mode. It just skipped right through to it. And there's 5 strips of 10 Neopixels behind the paper diffuser on the front. And there's a little bit of an issue with some noise on it, which is why occasionally the lights are flickering. It's not the code, it's actually I think one of the tracks of one of the LEDs is a little bit faulty, and it's interfering with the data stream, because the whole thing is being driven directly by one wire. So this is just the connection here. It's just 2 wires, one for ground, one for signal coming up. I've got a separate power supply feeding the LEDs because obviously the Uno will not drive enough to keep it going. And the rest of this with the Uno is just the another NRF board. So it's not directly connected. The only reason this USB is there is to provide some power to the Uno. And when I click different things, right now it's still running that expand. So if I tell it to go to rotate, once it's finished that expand, it should flip into the rotate mode. Give it a second to finish the expand. There. And it flips to rotate. I programmed it such that when you change modes, it'll finish the current mode. It has a cycle to go through, and then it will go and flip around. If I go to full auto mode now, it will actually start and go through all of its different patterns, which I've already shown you on a previous video. So what else have we got? Talked about baby Bob. We've talked about the LED strips. We've got minions everywhere. Minions everywhere. Gotta have the minions. If you don't know what that's about, well, you may well do if you keep up with the community. So what else have we got here that's of relevance that I want to talk about before I start, I don't know, posting code and things like that. See, you know, these lights, I've just stuck them on a piece of bracket of aluminum here so that it can show up. And I know you Brits are going to say it's supposed to be aluminium. Well, that's fine, but I've been in North America far too long to keep saying that. But I just did, so, you know, no offense for those Brits or Europeans that call it aluminium. I just got used to calling it aluminum. Never mind. Anyway, so yeah, battery powered, completely autonomous. The only power connection here is from my Keithley power supply, just for powering the high powered lights. Everything else is running completely off the battery, and it's using its own Wi-Fi connection. So basically I have a subscription from the web page coming from the temperature sensor of the Texas Instruments, and that's being monitored in real time. I've got one topic that I can push to for the display here, which is for the RGB LEDs. I've got another topic which I can transmit through to, which is for driving the NeoPixel star. I've got another topic which this send text can send to, which allows me to send random messages to the 32 by 64 pixel display that's connected to the 80 mega. And yeah, that's everything that is running here. And of course the subscriptions, the Raspberry Pi at the back. Oh, that's what I haven't shown you. There you go. See, I knew I'd remember here somewhere. On here, just back up a little bit. I'm just holding freehand. Apologies for that, because all right, so I'm using the Raspberry Pi. I've put the MQTT software on here, Mosquito. And what this one is, if I just Control-C this for a moment, it's actually not running anything. And what you'll see here at the bottom is it is monitoring, bring up the thing here. So you can see it's MQTT sub, iot.eclipse.org. And the topic is Element14 IoT. Another topic, the breadboard strip, which is the one that drives the Infineon board. And then NeoStar is driving the NeoPixel star, of course. And then you've got the other topic there, which is the BOB party, which I think is the one that's receiving the temperature. So I can actually tell on a Raspberry Pi to subscribe to all four of these all at the same time. I can even include subtopics if I want to. For instance, BYOB party does actually have two subtopics. And if I just press enter for that, so as you can see, can you see the whole screen here? Yep, you can. On the top screen here, what I've got on the top one is this is a Raspberry Pi terminal session using SSH, and I'm actually using publication. So this, I can send any message to the Element14 IoT just by hand. Like in this case, I just sent Jessica. That's my daughter's name. So that would have just pinged up. I know Fan and then we're wondering what the heck was going on with all that before. The bottom one, as I said, is that still visible? Yep, let me zoom in a little bit to that one. There we go. So this one is the subscription to all of the four topics that I'm currently using. So when I press enter, now it's just listening to all of them. So if I go to the web page here, it's going to lose the screen a second. I'll bring it back. If I start changing colors, send a bit of text, click rainbow. Now I'll go back to those. So I've clicked a few different topics and things here. And what you should see is here's all the me rotating the color wheel, sending all of these hexadecimal versions of the color codes. There's me sending the hello text, and there's me sending the NeoStar rainbow text. And these other ones, IoT, Jan Kumps and Peter Oakes, they're just the normal rotation. There's Van, where we're sending in the pings, as I said, every 30 seconds or so. So if I just move this over a little bit and just look at that screen, and if I put my finger very close to the temperature sensor, so what you want to do is watch the one on the left hand side, you should see it jumping up in temperature. Whoops, I touched it, and it's very, very sensitive to the temperature. I try and put my finger near it. As you can see, it's measuring the temperature in real time, and it's just pinging as fast as it can up and showing the temperatures. Oh, I did just notice something that's not working properly, because this thing should be showing me the temperatures. The reasons it's not is because the subscription isn't done quite right. So if I just break out of this and edit the subscription, so the BYOB party should have a /hash on it, which tells it to have everything underneath that, because I have two subtopics underneath BYOB party. One of them is for the room temperature and one of them is for the floor. Now I'm pretending that's the dance floor temperature, of course, but it could easily be anything else that you wanted to be monitoring. I'm just using it. There you go. Now it's bringing up, if I just zoom in a little bit on that, you'll see it's bringing up the temperature now every second, and that's actually being transmitted and reflected on these two displays because they have subscribed to it. So they will get it as well. Now this is just a standard HTML page with a whole bunch of JavaScript, and I will post all of it onto the forum so that you can all play with it, hack it around, use it for yourself and everything. But I just, as you can see, demonstrating here, I've got basically 5 separate topics all running, and I have a combination of different technologies and boards all communicating with each other and driving different things, both using serial LEDs, RGB LEDs, using the Infineon board. I'm using relays to drive more power loads. Now, of course, with the relay, if you've got the right relay and it's in a safe box, you can drive anything up to high powered loads, motors, fans, mains, lighting, and everything else. You just need to know what you're doing if you're going to go that way. If you're not, then there are other things that you can do to achieve the same kind of thing, and I'm going to actually put some videos together at a later date to show some options for that. The other thing I've got here, which we haven't talked about too much yet, just scanning by the minions down to this guy, is this is actually all what this one's running on is completely just a 80 mega tiny 85. So the reason why he's not doing much other than just monitoring a movement detector and a distance sensor is because, well, one, there's no pins left to hook up anything else, and two, there's no RAM left. Like, I don't have enough room to put any more code in there. So it's a little bit, I think if I reverted it to being coded using machine code instead of, or pure C rather than wiring, which is what we use to control most of these things, or to program most of these Arduinos and TI boards in, then I would be able to squeeze a lot more functionality in. But right now I've just been using wiring so that other people can use it and easily understand it. I think I've gone around this twice now, and I don't think there's anything else really that I could tell anybody. So I'm going to take some good quality snapshots of some of the things here so that you can see it. But I think that pretty much completes the Internet of Things holiday party. As you can see, it's quite a party. Everybody showed up. Everybody's talking with each other nicely, or at least those that can talk anyway. Some brought their own lights with them, like the Texas Instruments with these high-powered LEDs driven off their own supply and running autonomously. Anyway, so we've got the Raspberry Pi, we've got the Texas Instruments, we've got the Unos, we've got the Yuns, we've got the Megas, and we have the AT Tiny 85 as well, all happily participating in this festive holiday season light show. So I hope you like it. It's certainly been a huge challenge trying to get all of this done in time. It doesn't look like much when you just look at it on the bench here, but it has taken more effort than you can imagine. I mean, anybody else that's doing this challenge, if you've been doing more than just a single little bit of lights and you've wanted to do some things more challenging with this, and I know there's been a few of you out there that have, because I can, you can see by the number of posts and things that people are, and I think I've managed to get my kids involved as well, building the baby trinket, which became, of course, Baby Bob as he grew up from being just a trinket, and the Neo Star and things like that, and coming up with some patterns and various other aspects. So yeah, it's been fun, it's been a blast, and I think that pretty much covers off everything I want to say about the Internet of Holiday Lights, at least till next year. Anyway, see you soon. Thanks. Bye.